Okay, we're back a little bit onto Puff and Brake. This is the breadboard that we had about a week ago, and we had the green and red lights going, and we had the fan going, and then I replaced the fan with the smoke, and we had the smoke going, and then we had the chuff sound working. Oh, it was gorgeous. Now, this has to get reduced to something, and right now it looks like this, which is a little messy and ginormous to absorb. So I've been working on just what is it I need to put on a board. So I went through the functions. I got a transformer in, logic circuit 1, which is the go, logic circuit 2, which is the brake, the idle, which is straightforward, the relay trigger to turn the fan on and off, the different toggling mechanisms, and all of these bits go on a single PC. Okay, so then I said, okay, well, how are we going to arrange this? I started putting this together. So I got, here's a chip, there's a capacitor, there's a chip, there's a capacitor, there's a couple relays, there's a relay, there's a switch, and there's the big relay. And there's the motor just sort of theoretically sitting there, but ideally it would have power would go to the motor from here. And that fan motor is going to be in the front, mind you. Okay. So then I got a bare piece of what I call perf board. It's a board with holes, but no tracks. Okay. It has no logic into it. And I just started putting parts that would symbolize or be the parts that we would put in. So right away, the switches are all wired out. So I put the switches coming in from here because they sit on here and we get the wire, right? We get the wire from the switch, but we're not the switch. So all we do is we worry about the wire on this PC board. So the wires come in here for that. Power for the relay, and power for the idle fan are all coming into the outside. Then the motor is where this goes out to, the fan motor is what we said. And then over here, the two logic circuits, go and break. And when I build these components, and I don't know why it's not so bright here, but it's not very bright on my phone anyway, that is remarkably small. I would think you're going to have connections going out, but this power comes in, goes through a relay, goes to pin 1 of a chip. Power comes in, goes to 2 resistors, and then to pin 1, and then the other one goes to ground. Well, there's 3. The 2 chips are these MOSFETs. So I have them only in surface mount. You can get them in a configuration like like the power chips that we're using over here, and I will do that. And then I have capacitors, and then I have a relay. These are all like logical parts. They're holding the space. It ideally could look like it would be smaller than this, right? I mean, there's not that much on here. And I've checked, I went through and did a little extra little check marks. Yeah, I've got everything on here. Okay. I couldn't find the relays. I'm looking all over. I have the old relay, which is as big as your thumb, right? I have this relay, which I can't pick up because it's so big. But what I needed was this tiny little relay, the one that works. I looked high and low. I went through all my boxes because we had the big cleanup. It's so small. It's in a tube, and it was sitting here the whole time. Yes, I know, the big cleanup, that big help, right? Okay. So what I have been able to do is identify the how should I say, the footprint of what this is going to require, and it's not very big. I've got the basic components, size and shape. Now what I don't have is the two froms as far as the wiring or the tracks. And what I do when I build these, I just use my preformed wire, and I'll run it as if it's a track. I'll just run these two are connected there, so I'm just going to glob solder. If this thing has to come down to here, I'm going to run a little wire and poke it in a hole, and then glob solder connect the holes. So that's going to take a little more real estate than if it was a real life PC board, but at least it's going to get me a module that I can put on an engine and test that way. Then what I would do after I get all this built, tested, and it's working the way I want, I document what I have done, the routing, the to-froms, the parts, the locations, and then I give that to somebody. I pray it's either Andy or Robert, and they are able to create the PC board file that we need then to get made. That's how I'm hoping it works, because I could probably do it, but it'd take me a month to learn how, and that'd be ridiculous. These guys could do it in an hour. They can do it. I don't know. They're not sending them any money. I mean, we're just friends. Hey, friend, help me. How many times can you do that? I don't know. Andy's been awful good about it, but you know what? You can wear out your welcomes too. So, in any case, there we are near the end of the day, and I thought I'd better. I said I washed my car. That was my thing. I did it. By God, my car shines like a diamond in a goat's backside. Okay. Now, the other thing I wanted to do was get this PC board started. And this is the perf board is the next step. After you get the breadboard, you go to the perf board, then you build the board. Okay. So I'm going to have to get real life chips. Now, I can make chips like I did here. I took a surface mount and soldered it to those leads. So I could actually use that part, put it in there. I could use these things. They're, I don't know, they're like capacitors, but they're funny. I have to read up on them and make sure I'm doing the right thing. But I could take these parts and use them. And I have a couple spares over here, actually. I could probably do that. Then what? Then the relay, I got a bag of relays. So I got a relay right there. I got the resistors right there. Boom. I got all the parts, okay? I have to take the board. I have to create this layout on real live, a square as a whole kind of a thing. And then say, okay, well, there's a part, this part is sitting here. And for grins, I have this part sitting here. And this pin goes to this pin goes to this pin. So then what I'll do is I'll put a blob, I'll put a wire in here like this. And then I'll just do a blob of solder between the two that are supposed to be connected. That's how I'll build this out. And like when power is on, I have power coming in here, and then I'll put a power wire here. Oh, there's a relay, but don't worry. Okay, here's a relay. Put the relay there. Okay, fine. Then that wire, then I'll pull that wire over to here, and then we'll just blob that in. Okay. So, okay, there's the relay, and then there's the power. Oh, right, geez, oh, peace. And then wherever this goes, same thing. Put a blob, wherever it needs to go, you hook it up. So it's going to look messy, but it's going to be a lot better than that. It'll be more reliable because pieces are going to be soldered together instead of just sitting in a pin thing. Uh-oh, I hear footprints coming to the basement door. I don't hear anything. Still have time. Okay. Then that's what I'm going to try to do. I'm going to try to do it tomorrow. She thinks I'm going to take her grocery shopping. Good God, how many times do we have to shop for groceries? Oh, we're low on this and that. Oh, no. Anyway, I got somewhere. I washed my car. I feel so good about it. Well, I did do some other stuff. I worked on the O-gauge powered rolling road. Got built 2.0, you might think of it, for testing. I need some people to test that. And I built a new cam for the motor. And then I'm going to work on a new design and shape of this piece here for this to just see, can this be repeatable and reliable? Can it? I'm not convinced. I mean, it worked okay, but I'm not convinced. Limit switch with the cam is pretty straightforward. And then, of course, we go back to the Hall effects, which I gave up on because I didn't know how to build the right circuit. The switch is built for Arduino signaling, not, closing the circuit. So I have to figure out how I can do that. Oh, the other thing I'm going to have to fuss about is the on-off aspect of the relay. What turns it on? Where is that logic? It could be on this board. That may be something I have to add. I'm going to write that note relay logic for on-off. Because when the transformer is on, when the motor control board has power, that should have power. When the motor does not have power, then this would not have power, and then we're in idle circuit, which is a hardwire, in normally closed. So when it does get power, it goes to normally open, and then it links up to the output of the motor controller, which then would be turning on the fan. That means I want smoke. The motor's turning, we need smoke. Okay. My soldering iron is telling me I haven't used it in 20 minutes. I'm going to turn off if you don't pay attention to me. It's like a golden retriever or something like that. You know, if you don't touch them, they get wigged out. Okay, that's it. That's what I'm going to do tomorrow after groceries. God, jeez. It's only an hour, I know, but it takes me an hour just to start something. Because my brain is so clogged. I don't know, overloaded, slow and tiny. I don't know what it is. But at any rate, we're getting there. Now, this mess gets down to this board. That's pretty neat. I think that's pretty cool. And I looked again. I thought, is that really it? Is that all it takes? And I looked at this. I go, oh, well, we got a lot of extra in there. We're not going to use it. Okay, well, then there it is. All right, I'm excited. Progress. I'm just going to leave this right here. I don't care what she says. This is staying out. And by God, when I come back down, this is where I'm starting. All right, gang. Have a good day. Mine was pretty good. Played some ABBA. You bet. Went to my happy place. Went out and looked at the car again. Oh, it's so pretty. Okay, I'm done.